Assalamualaikum warahmatullahi wabarakatuh to my supervisor, Professor Mustafa, and to Prof. Tarek and to Prof. Dr. Dayang. Today, I'm here to present my final year project on development of effective impact damage detection method on imaging software using active tomography imaging and Internet of Things IoT. First of all, we begin with the content for today's presentation. Start from introduction, which includes project background, problem statement, aim and objectives, and scope of the project, and then followed by literature review, methodology, result and discussion, conclusion, references. We begin with the introduction. So for the project background, composite materials have been widely used in aircraft structures such as fuselage, spoilers, flight controls, and wing. Advantages for aerospace field: there are low weight, high strength, and better corrosion resistance compared to metal or wood. Plant-based fiber composites are very popular for their eco-friendly property, and among plant-based fiber composites, flex fibers have been considered for the primary aircraft structure and to aid with the development of variable pitch aircraft propellers. So on the right hand side here, these are the example of the flat fiber composite. All right. And composite material face crack or corrosion in lesser probability compared to metals, but these materials are very much prone to be exposed to impact damages, micro crack, fiber breakage, and delamination, which can cause the structural failure. And this type of damages dissipate heat. Thus, one of the suitable methods for detection would be active tomography. And the need of this research are examining process is expected to be carried out as soon as possible, and the current system is mostly offline and the data transfer takes a long time. Therefore, it is very important to carry out an inspection now and then to study the behavior of the material. And for Internet of Things application, as a primary interface, a mobile application would be suitable to be employed in NDT techniques. The use of mobile application varies as it is easier device to carry anywhere. Since right now everyone have their own smartphone, so the result can be carried out at anywhere. And the user can access information anytime that there is an internet connection. For problem statement, due to the aircraft limited downtime, the aircraft is expected to be inspected quickly and accurately. Naturally, the inspection process takes time because the inspecting surface is huge for aircraft. Thus, the time had to be saved at processing and analyzing results. And another problem is that to obtain the process data, current technology uses the method of importing the data into an external drive and processing it, which needs time and takes up storage. And there are two solutions. First, the data obtained can be accessed online via a mobile application, and it does not require much storage as saving the images in external drive. Second, it is accessible from everywhere and it is easier to use to get the data about the impact effect. Okay. For aim and objectives, the aim is to provide the result of the study in a web-based framework and to notify the user through application. And for the objectives, there are three objectives that I have created. So first one is to minimize data transmission time by establishing a mobile application, and to analyze the capabilities of active infrared tomography images and detect impact damage using image processing. And the third objective is to assess the effectiveness of the developed application of the imaging software in detecting damage. And overall, the scope of the project is analysis of impact defects on flex composite laminate through the application of image processing technique, analyzing composite panel for crack detection, last but not least, to detect defects in composite material. And the thermography method is the most effective one. Alright, so next, literature review. So the first one is image acquisition. There are three types of image acquisitions. First is the digital camera, infrared camera, and thermal camera. For image acquisition is to capture for analysis of impact. The image obtained has some correction to be done, and researchers use infrared camera to detect impact defects because it is visible and clear to be seen. Next is thermography. There are several types of thermography used to detect impact defects in this literature review, such as infrared thermography, vibothermography, induction thermography, and eddy current thermography. An active thermography requires a heating or excitation source to heat the sample so that the detection could be done and the damage could be viewed clearly. And this heating or the excitation source varies according to the type of thermography and also the purpose of the research, where some use ultraviolet light heating rod, laser beam, induced current, and vibrational excitation. So based on this literature review, infrared thermography could detect the impact damage well and is commonly used by researchers as it does not require high precision as for crack detection. Vibothermography, induction thermography, and eddy current thermography require additional setup for it to work, where the excitation source is different and the image processing is also complicated. So apart from that, there were also stationary and moving mode sample used by researchers to test the camera FPS. FPS is the frame rate. Right. Alright, and next, image processing. From the literature review, we learned that pre-processing is essential, where we change the image to grayscale to reduce taking up space and to reduce complication to be processed, since color images need to be adjusted based on their RGB value. And there were two main filters that were used by me to enhance the image, which are the median filter to smoothen the image and also thresholding for image segmentation. So comparison of researchers were carried out on segmentation method, including k-means algorithm, watershed algorithm, and it was deducted that also thresholding method is more effective because it could separate the defect from the background. So that is the reason I use also thresholding filter. And there were two main smoothing image filter were used among the researchers for their image processing, which are the median and the Gaussian blur. Alright, and then morphological filters was applied in some of these projects, such as open, close, erosion, or dilatation, to make the impact damage more visible. However, there were certain reflection problems faced by researchers, which is caused by surface or the surrounding object. Alright. And then next one is Internet of Things, the main thing of this project. First one is the ability to transmit data over a network without the need of direct human-to-human or human-to-computer interaction. Produce the device as simple to use as as possible for individuals who will be using it for impact detection. And IoT can be carried out from any location at any time. Easy for the user to browse the website. Web-based framework will be built to access the data of the crack using the Flash framework along with the Python programming language. And last one is the usage of the Raspberry Pi. Okay, and next one is the methodology. This is the general methodology of this research. We begin with the set up the device, and then device integration, and then image obtained with thermography, which will be shown later, and then employing software to perform image processing, and then mobile application development. And after we do the image processing, the result will be shown on the mobile application. Alright, and then the thermography process was done by the source, thus the result from the thermography is from the reference 24. A low-cost thermography equipment was developed with basic user interface, the low-resolution thermal camera, and image processing was done in the ImageJ software. And the user interface is by using mobile application for this project. Right. So first methodology is the experiment setup. So the samples are made of the flex composite. There are totally 4 samples were used into with 2 types, which are the lightning defect and drop weight impact. 2 models of low resolution infrared camera were used to capture the thermographic image, and the infrared camera called FLIR Lepton 3.5 and LWIR camera and thermo imager TIM 200, and 2 halogen lamp to heat up the sample for thermography. So these are the 2 halogen lamp just to heat up the samples so the infrared camera can detect the defect. All right, and this is the step when I conduct the image processing. So first, with the pre-processing convert to the grayscale, the recommendation is 8-bit, and then improve image intensity by adjusting the brightness and the contrast, and then apply the median filter, and then improve image intensity by subtracting the background, and then find the edge to make the defect more clearer, and then image segmentation also threshold. For this step also thresholding, I use the plugin method from I download the plugin method from the internet because I see that it is more precise compared to use the manual also thresholding in the image software. Then after that, apply the morphological filters such as the erode and dilatation. Okay. So image from tomography was processed locally in software called ImageJ, and pre-processing convert to grayscale due to less amount of data consumed and less complicated. And based on literature review, certain filters were chosen and applied while while processing the thermography image, such as the median filter, also threshold, Sobel edge detection, and etc. Right. And this is the application of Internet of Things. So we begin with when I conduct the coding to make the application. First, download the Android Studio, and then configure the Flutter and Dart plugin. Configure the Visual Studio Code. The reason that I use Visual Studio Code is because I developed the application that can work on the Android Studio and also in the Google Chrome by conducting the code in Visual Studio Code software, because as we know that the app cannot work on its own, So sometimes Android Studio software is very hard to work with due to it consumes a lot of data and storage in our devices, and that will lead to make our device stop at some point. That's why I conduct the code in another platform, which is Visual Studio Code software, to make it easily to play around with the app via Google Chrome, and it consumes very less storage compared to Android Studio. And in the Visual Studio Code can also choose to open with the emulator on Android Studio as well. So that's the benefit of it. Okay, so we back to this. So after that, create new Flutter project. So uh, Flutter, the Flutter is this application needs to install the Flutter, because like I said that the Flutter can the application cannot work on its own. So the Flutter is to create the need to install we have to install the Flutter to create the code and emulator. And the Flutter is the tool that work together with the Android Studio and Visual Studio Code software. So without the Flutter, the app won't work. Alright, and the next, does it work on emulator? If yes, so continue with the code, and then input the layout, widgets, navigation, and so forth. Import packages, and then data upload and synchronization. And then if it works on emulator, so the app is work. Okay. Application of Internet of Things is the main purpose of this mobile application is to view the result in form of images from the thermography and the image processing. And it was built with Flutter, a software development kit by Google. Use the Dart programming language also. And Android Studio was also set up to use the emulators to test the code functionally. Okay, so here is the results and discussion. Images. These four images show the samples that were used. The samples that are used is from flex fiber composite material. Material is the lightning strike with copper outer ply embedded with embedded wire mesh, and material B is impact defect which have wire mesh embedded in them. Material C is non-wire mesh lining defect, and material D is lining defect alongside the implanted wire mesh. So here is the image that I have obtained from the thermography. So before I conduct the image processing, I I found the issue. I already did the image processing, but then I found the issue. I cannot process the image. The issue is I had to adjust the image into the certain pixel first, so that it won't be distorted. So here is the picture after I adjust the pixel, and then here is the final result after the image processing for sample one. Sample one less noise on the thermography image, and after process the lining defect is clearly visible. Same goes with the sample 2, sample 3, and sample 4. I had to adjust the certain pixel value. So for the sample 2, before process, the temperature distribution is very noisy. So after processing, grainy image smoothing while before get the final result, I had to apply the median filter, and then after process image, 2 points impact defect visible with the minimal noise. For sample 3, before process the image, the temperature distribution is noisy for the thermography image. And then after that, defect is very clear after increasing image intensity and applying median filter. And after post processing, some noise is still present at the end. Okay, and then for the last sample, before do the image processing, the temperature distribution is very noisy. You can see from here. And then the original defect is at the center grainy image here, right here. So after post-processing, the defect is visible as well as the noisy surrounding it. There are still some noisy surrounding it here. Alright, so the image processing is done. So these are the post-processing surface plot for each sample. By using grayscale representation, we can observe how the different shades saturation changes as they go up and down. For this example, the black region has a 0 pixel value right here, while the pixel maximum value is 255. A greater pixel value indicates that the region in question is flawed, so the surface damage was solely analyzed and the depth of damage was not addressed. And apart from that, by using the surface plot, it is clear that the dark area with a 0 pixel values does not have an issue. There is only a problem in any position where are 255 pixel values. So at the top, there are always the problem. By using sample A as an example, the contour plot shows a higher z-axis pixel value in the sample midsection where there is a defect for sample A. So to put in another way, after image processing, a larger pixel value on the z-axis may show damage to sample. So no matter how much noise was removed, the processed image still had an inconsistent contour plot. Alright, and next one, after the post processing, we begin with the mobile application. So here is the flow of the thermal image mobile application. The thermal image is the name of the app that I name it. So when we begin with the app, we can see the main page, the home page, and then the raw data. The raw data will show all the 4 samples, and then there is a button called process image that will show the process of all 4 samples. So the overall of the application consists of 12 pages. Okay, and then after this, I will show you the actual image of the application. Here is how the application look like. Here is the screenshot of the main page of the application on the emulator. So when we click discover, after we click discover, it will be like this. It will show the raw data and process image. This is the screenshot of the page of the application on the emulator. So if we click the raw data, it will show all 4 samples. So if we want to see sample 1, we click sample 1. We show like this: the raw image, the actual image, and then the thermography image. And then, all right, so here is the process image page. This is how it looks. So if you remember at the main page, after we click the discover, right? So we begin with that. After that, will be shown the home page will be shown the raw data button and process image button. So for this page, if we click that process image button, it will show the post it will show the whole step of the image processing. So as for example, for this sample 1, it shows the first step of image processing that apply the median filter, and it also shows the app also shows the definition of it. So this is how the process image on the application look like. Right. And then for conclusion, this project managed to process the image from the infrared thermography and identify the impact defect with the aid of image processing feature in images software for all 4 samples. A mobile application named the Thermo image was developed. The image The images from thermography and image processing could be accessed online through this application. It is accessible to Android users with the target Android 8.1 operating system. And last but not least, this application was tested on two types of emulator using the same operating system but different dimensions and internal memory. Okay. So here are the references that I have been using for this project. There are still many more. Okay. In the report, there are still many more that I have used, but this is just some of it that I use for the slide. Okay. So I think that's all from me for today. Thank you very much. Thank you for listening. I hope you enjoy. Assalamualaikum warahmatullahi wabarakatuh.